Hello, I hope we're having a great day. I want to unpack 4 strategies we can use for subtraction. There's also another strategy called removal. I don't think it's that efficient, so I really am not sharing it, sorry. But I want to look at, so often we go to the algorithm, which is not a bad strategy, and it's something that will always work for children, but so often it doesn't allow children to gain numeracy because they don't really understand how it works, they just do it as a rule. Adding up in chunks allows us to do mental math. That's really why I encourage the adding up in chunks. Keeping a constant difference is actually a very efficient strategy that very often children will use when they work with 2 and 3 digit numbers because they recognize how flexible it is they can be with numbers. Place value negative numbers is just, again, getting them realizing the relationship of numbers and actually introducing them to negative numbers, or I should say debt. I think debt's an easier way to describe it to children. So let's first look at adding up in chunks. What if we had 36 lose 17? Okay? And if adding up in chunks, if we think about this, well, 17, we're going to end up at 36. So 17 plus 10 gets us to 27. 27 plus 3 gets us to 30. 30 plus 6 gets us to 36. So we know the total difference between 17 and 36 is a difference of 19. Now, keeping a constant difference just says, okay, we want to work with friendly numbers. Wouldn't it be a lot easier to work with 20 instead of 17? Because it's a friendly 10, it's 2 10s. So again, whatever we do to the minuend, we have to do the subtrahend. So if we're going to add if we're going to add 3 to 7, we have to add 3 to 6, or 36. So we'd be left with 39. So 39 minus 20, again, gives us that answer of 18. The other thing we can look at when we're playing around with this is thinking about when we think about borrowing. I highly encourage us to borrow at first where we're actually showing the children the number in expanded form so we can bring it to life. So often we'll do this with them. We'll say, oh, well, here's 36, here's 17. We say, oh, well, we can't take 7 from 6. We're going to borrow from the 3. We'll make that a 2, make that a 1. Well, let's bring the language to life so the children know what it means. So if we're borrowing because we have 30 piles here. So if we take away 10, take away one of the piles, we have 20 left. So we're going to take away 10. So now we have 16 in this pile. So 16 take away 7 gives us that 9. 20 take away 10 gives us that 10. We know 10 plus 9 is 19. Because then it's not, again, when we get into this, we're giving them a rule that really is not about numeracy. It's about them memorizing a rule, and maybe they understand it, maybe they don't. Where if we keep it grounded in the why instead of the how. Another one to look at is the place value negative numbers. And the neat thing about this one is again, it can be very challenging for some children, but for some of the children, they get really excited to see this. And you say, hey, I want to show you something else you can do. And the idea is, if you think about debt, again, if we show it on a vertical number line, if I started at 6, so if I had a diving board that's 6 feet off the ground and I dove 7 feet down, wouldn't I go a foot underwater? So wouldn't I be at negative 1? Because from 6 to 0 is 6, and then the extra 1. Wouldn't that be? So 6 lose 7 is a debt of 1. Or if we think about money, if I had $6 and I write a check for $7, I'm in debt $1. And then 30 minus 10 is 20. So 20 lose 1 is, again, 19. So those are just different ways that we can do subtraction and kind of have some fun with it. And also it's neat to show the children because it gets them realizing all the different ways that numbers work and how we can connect them together. I hope this something's useful and look forward to continuing to share ideas. Thank you. In the algorithm would have us say 30 plus 5, 10 plus 7. We say, well, I can't technically take away 7 from 5. If I only had the 5 M&Ms, I can't take 7 away. I'm going to borrow from the 30, make that 20. I'm going to borrow 10, So 15 lose 7 is 8, 20 lose 10 is 10, and then there's our 18. Now the place value in negative numbers, it does expanded form like the algorithm can when we first explain it. The difference is it allows children to think about numbers in terms of debt, in terms of negative numbers, but I like the language of debt because they can relate to that idea. If I had 5 and I lose 7, wouldn't I be at a debt of 2? If I have 30 lose 10, I'm at 20. Well, what's 20 lose 2? I still got my answer of 18. So again, just different things to consider when we're thinking about those different strategies. And when we're thinking about the algorithm, highly, highly encourage. I know so often we'll do this, where we'll say to a child, oh, well, you can't take 7 from 5, you're going to borrow from the 3. Well, no, technically that's a 30, so we're going to borrow 20 from 30. That's why I like to write an expanded form first, to just justify for them where it's coming from. Again, using place value cubes is another very useful strategy, so children realize how you're breaking 10 down into ones. So when we're borrowing 10 ones to make that 15 so that we can come up with that solution. And then the negative numbers, place value negative numbers, again, I call it debt, not negative. 5 lose 7. I hope this helps, and enjoy, and we will follow up soon. Be safe.